Hello everyone. Today we see some more problems on a ionic product of water. So these are very important problems and very few models are there and they are very important. Okay, see the first one. So the calculate the proton. So the proton means H plus and hydroxyl OH minus ion concentrations of centimolar sulfuric acid. Here this is important, centimolar. So what is mean by centimolar? So you have to remember this every time. Centimolar. Molar means it's given molarity in moles per liter. Centi means that is given 0.01 molarity. Centimolar means 0.01. Sometimes it is also given decimolar. Decimolar means that is 0.1. In this problem it is given centi, that is called as 0.01 moles per liter molarity. So what is that sulfuric acid? So 0.01 m of sulfuric acid. We have to find the H plus concentration in it. So we know that H2SO4 on decomposition releases 2H plus and SO4 minus 2. Means 1 mole of H2SO4. Here important thing, 1 mole of H2SO4 can release 2 moles of H plus. So means if you want to get the H plus ion concentration, that is 2 into H2SO4 concentration, because 1 mole releasing 2 moles of H plus. So if you want to get the H plus ion concentration, it is equal to 2 into H2SO4. So that is equal to 2 into, what is H2SO4 concentration is given? 0.01. So we will get 0.02 m. So we can write it as 2 into 10 to the power of minus 2 moles per liter. Okay, this is H plus ion. Now we got the proton concentration. Next we have to calculate the hydroxyl OH minus. So we got H plus equal how much? 2 into 10 power minus 2. So now we calculate in the second step, we calculate the OH minus concentration. So we know that H plus into OH minus, ionic product, we know that H plus into OH minus equal Kw, there is 1 into 10 to the power minus 14 m square. You see, capital M square means moles square per liter square. Just in simplifying, we are writing as a capital M square. Capital M square means nothing but moles square per liter square. So we have to calculate OH minus. So 14 by H plus. H plus how much? 2 into 10 power minus 2. So here moles square, moles will cancel, remaining moles will be there. So 1 by 2 we can write 0.5 minus 14 10 square. So we are increasing value here, we are decreasing the value. So this is OH minus hydroxyl ion concentration. This is H plus ion concentration. Okay. So next see the one more problem. Next it is given that K, acid dissociation constant for HF. Here one point you have to remember, that the acid dissociation constant generally is given for weak acids. For Kb, base dissociation constant is generally given for weak bases. For strong bases, generally 100% of dissociation will be there. So that's why there is no need of Ka and Kb in the matter of strong acids or strong bases. We know that HF is also a normal acid. Okay. So K for HF is given that so 3.2 into 10 to the power of minus 4 To calculate the percentage of dissociation. Calculate the percentage of dissociation in 0.02 m HF solution. Okay, so here we have to find the dissociation, not just dissociation. We have to find the percentage dissociation. So we know that percentage dissociation nothing but also known as degree of dissociation. That is alpha into 100. What is the difference in the alpha and 100 means? So alpha and degree of dissociation means alpha just indicates the extent of dissociation. Alpha indicates only extent of dissociation. Next, if you want to get into percentage, nothing but in terms of degree of dissociation, we do in terms of percentage, that is alpha into 100. Okay, so K is given. So with the help of given details, we have to select the formula. So it is given -4. K is a constant, has no units. And the concentration is given, concentration of HF is given 0.02 m. So see the percentage dissociation, we have to find the percentage dissociation. So what is percentage dissociation means? We have to remember that is alpha into 100 is called percentage dissociation. We have to find this. But here we don't know about alpha. Alpha is not given. So K is given, C is given. We know the formulas. Alpha is equal to root K by C. So what is it? K? 3.2 into 10 to the power -4. So next we can write so remember the equation 1. The main important just to remember the root value. Okay, so here it can be written as alpha equal to 32 -2, it comes to +2, it's a 10 power -2 root. So after all we will get here we want to know, we have to know the root 1.6 value. Okay, just wait. Root 1.6 value is 1.26 into 10 power -1. So here we got the alpha value. So but we have to get the degree of dissociation. Degree of dissociation nothing but according to equation 1, percentage of dissociation. Percentage of dissociation equal alpha into 100 -1 into 100 means 10 squared becomes 10. That is a 12.6 percentage. So the degree of dissociation nothing but percentage of dissociation is 12.6%. Just remember alpha is different, degree of dissociation is different. Okay, see the next one. At a certain temperature, the hydroxyl ion concentration. The hydroxyl ion concentration of pure water is given as 8.4 into 10 power minus 8 molar. Have to calculate the ionic product. So calculate the ionic product of water. So here the key point is pure water. So here it is given pure water means we know that in pure water, why separately mentioned pure water in the place of water means we know that what is the nature of pure water. Pure water in nature is neutral. Neutral means the concentration of H plus is equal to concentration of OH minus. Okay, so it is the key point in this problem. So pure water is neutral in nature. So pure water is neutral, therefore we can write H plus equals OH minus. So the hydroxyl ion concentration is given 8.4 into 10 power minus 8. So that will be equal to H plus also. So both are having same concentration. So we have to find the ionic product. Ionic product of water Kw. H plus into OH minus. So both are same. Okay. So 10 power minus 16. So on this calculation, so I already done the calculation, but where it is, just wait. 8.4. So it is approximately '. So let's continue this. The Kw equal, finally we will get 70.56 on this calculation. We will get 70.56 or minus 16. So 70.5 approximately we can take a 71. Okay, so there is a 71 into 10 power minus 16. I think in the options it is given in terms of 7.1. So value decreased, just increase the value. So there is a mole square or liter square, or we can write m square. Okay, so this is the answer. Okay, see one more problem. So here it is given the dissociation constant of water. Dissociation constant of water at a particular temperature that is given 306 Kelvin is given as 1.79 into 10 power minus 15. Head point, what is the ionic product of water? What is the ionic product of water at the temperature? So So that's important word for exact temperature. So here the temperature is very important point. Actually we don't use the temperature in the calculation, but why it is mentioned separately the given temperature means we know the ionic product of water directly proportional to temperature. As temperature increases, ionic product also increases because degree of ionization of water increases. That's why it's what is we can say Kw value increases. Okay, the dissociation constant of water. So we know that water reaction H minus, we can write the equilibrium constant K is equal to H plus into OH minus by H2O concentration. So actually here the dissociation constant is given means so here the given value K is equal to K value is given as 1.79 into 10 power minus 15. So this is a somewhat important problem compared to others because it is somewhat confusion is there. So say K equal in the place of H plus into OH minus we can write KW and H2. So just take it as equation 1. Now see about the values. So what is the K value? Actually we have to find the KW. So K is given what? K means here we are taking as the Ka, not adding acid dissociation constant. Here we are taking the Ka for dissociation constant of water. Okay, you can write just K also. 1.79 into 10 power minus 15. So then here important thing is what is the H2O concentration. So it is very important. H2O concentration we have to take in moles per liter. Okay, the standard value we take moles per liter. So H2O in moles per liter means how much we'll get. So H2O moles per liter. Okay, H2O concentration means moles per liter. So we have to calculate it for liter per liter. Okay, what is the number of moles? Number of mole means weight. Weight we are taking as 1000 grams. So here important why we are taking 1000 grams means we are calculating it for 1 liter. 1 liter means how many milliliter? 1000 milliliters. We know the density of water is 1 gram per milliliter. The density of water is 1 gram per milliliter or 1 gram per cc antam. At 1 cc 1 milliliter weight at the 1 gram. Water ki perfect foot avutadi. 1 milliliter equal 1 gram. So for 1 liter ante 1000 milliliter is 1000 gram weight by. So molecular weight per liter kabatti again it is just equal to 1 only. Okay, number of moles. On this overall calculation we will get 55.5. Now substitute all these values in equation 1. So I am changing the equation 1 as Kw is equal to K into H2. So what is the K? H2O. So on this calculation we will get that is just right. It is 1.79. So on this calculation here we get 99.345 into 10 to the power of minus 15. So then, for the simplicity, we can write it is as 100. Okay. kW, so there is a mole square per liter square, or we can write molarity square. Okay, so these are the main problems on this. So there is one more problem is there. It's an important one. So it is given that the concentration of H3O plus H3O plus ions is given H3O plus of aqueous barium hydroxide. Aqueous barium hydroxide is so given as 5 into 10⁻⁹, sorry, S minus 9 moles per liter. What is the molar concentration? Molar. So here see, molar concentration means we have to find the concentration in terms of molarity. If it is given molar, so we have to find the concentration in terms of molality. Okay, so find the molar concentration. The molar concentration of barium hydroxide. Okay, see, you have to find the molar concentration means we have to calculate the in terms of molarity to the barium hydroxide solution. So what is the given information? The information is given about the proton concentration. Proton concentration nothing but here it is given hydronium ion concentration of aqueous solution. So first we see what is the barium hydroxide dissociation. So barium hydroxide dissociation, we know that Ba plus 2 and 2OH minus means 1 mole of barium hydroxide can release 2 moles of OH minus ion concentration. Means here the OH minus ion concentration is equal to 2 into barium hydroxide concentration. Okay, so it's the important step here. So 1 mole can release 2 moles of OH minus means the OH minus ion concentration is equal to so 2 into barium hydroxide concentration. Okay, so here we will get so actually in the problem we have to find the concentration of barium hydroxide. So therefore barium hydroxide concentration is equal to OH minus concentration by 2. Okay, just take it as equation 1. Means to get the barium hydroxide concentration we have to know the OH minus hydroxide ion concentration. But in the problem it is given the clue is in terms of proton, nothing but in terms of H3O plus. So take it as case 2. We know that H plus into OH minus equal to Kw. So here we have to know calculate OH minus, that is Kw by H plus. H plus, or you can write H3O plus also. For Kw we have two formulas, H plus into OH minus or H3O plus into OH. You can write any one. But in this problem it is given in terms of H3O, we are writing H3O plus. This is called hydronium ion concentration. No change in the numerical values. So what is the Kw? 1.0 into 10⁻⁴ mole square per liter square. H3O plus is given in the problem, that is 5 into 10 to the power of minus 9 moles per liter. Moles per liter cancel, 1 moles per liter will be there. That's 1 by 5. We write 0.2 into minus 9 plus 9. Okay, it comes to 6. Okay, so 5. It's just 5 moles per liter. So the concentration of OH minus is 0.2. 2 into 10 to the power minus 5. Now substitute in equation 1 to know the barium hydroxide concentration. So just take it as step 3. Okay. So barium hydroxide concentration OH minus 0.2 into 10 to the power minus 5 moles per liter. So that is equal to, we get 0.1 minus 5. So I think in the options it is given 0.6. So concentration curve is for the moles per liter. In the place of moles per liter, we can add the molarity M. So very few formulas are there. Just in the formulas only, the repetition of the formulas, interrelation between the formulas, there is a problems are there. So in the worksheet I given, so the problems are very similar to these problems. Okay, just you have to know how to write which formula should be used for the given problem. Okay.